Good morning, everyone. Happy to be here to share Huawei's view on what kind of data infrastructure we have to do, particularly when generative AI comes. We all know data storage is keep evolving. When we have a database and a virtualization, we start to have DAS and also SAN storage. When we needed to share the files through the internet, and then we start to have NAS, that kind of storage. And when big data becomes very important, and also we needed to do a lot of high-performance data analysis job, for example, HPC, and also gene analysis, these kind of application. And then we start to develop unstructured data storage. And these unstructured data storage can support big amount of data, and also more data paradigm. For example, Objective, Hadoop can all be supported. And now, generative AI comes. Generative AI, the application, is very much different from what we have in the before. We need a big amount of data with different paradigm to support these kind of algorithms run with efficiency. And also, it's big cluster. Energy consumption becomes very more important. And also, the efficiency of the GPU and the problem recovery, all of these issues really brings difference from previous application. And then we think it's the right time to define the new generation of data storage. Generative AI, the big problem it has is efficiency. Today, most of the data center of GPU, the efficiency and also the utility of the GPU is less than 50%. That means most of the time of so expensive GPU, they are waiting. They are waiting for feeding the data. They are waiting for recovering the problems. So the efficiency, the utility of the GPU is really the key factor to design the data infrastructure. Because of the efficiency, and then energy becomes a problem. Today, in some of the countries, we lack of silicon, basically GPU. And tomorrow, we definitely believe we lack of energy, and then lack of data. 50% of the data center energy will be used for GPU. In 2026, we can foresee the energy used for those data centers somehow equivalent to the total energy consumed in Japan. Today, if we use ChatGPT to understand 1,000 characters, it needs to spend a lot of energy, somehow equivalent to 1,000 family energy used for 1 year. So the efficiency is really the key facts for the generative AI data center. And data storage must support to keep improving the energy consumption and the utility of the GPU. So it's the right time to define next generation data storage to fulfill this mission. As you know, the traditional data storage has 3 dimensions: performance, reliability, and also data paradigm. For next generation data storage, we still need to keep these dimensions, but with much stronger performance. Ultra performance, 10 times performance, PB level bandwidth, 100 million, that kind of level of IOPS is needed. And then data resilience, not just the reliability. We also need ransomware, that kind of prevention algorithm and capability be embedded. And very important, new data paradigm needed to be supported to support generative AI. For example, vector. For example, tensor. Furthermore, we also need 3 more new dimensions. The first one is data fabric. Today, in one company, data is everywhere, but the CEO doesn't know where is the data asset, how to use it. The metadata within the data storage can help us to organize well on all of these data assets, to make CEO understand where is the data asset, how to use it. On the other hand, scalability. We need very good scalability for scale out, therefore to support EB level capacity expansion. And very important, we also need scale up that kind of capability by adding DPU or GPU or CPU adapter into the data storage, and then to facilitate closed data storage, that kind of computation. This is very important for future utility. Today, a lot of data moving between the computer and also the storage. A lot of energy, some people say 60% of the energy was wasted by those data mobility. And the last, sustainability, which is very important. We need a green technology to save the energy. Therefore, we need 1 terabyte really have less than 1 watt, that kind of power consumption, lower. And also, per unit, the density need to support more than 1 petabyte. So that kind of performance is what we needed. Therefore, to define new generation data storage, we need 6-dimension capability. How to do that? We have answer. Let's have a video. This is our new generation data storage, OceanStor A800, which is AI ready and also with ultra performance, 500 gigabytes bandwidth, 4 times than what we have in this world right now. And also, the IOPS will reach 24 mega. And it's 8 times what we have today. And also the scalability is really strong. 512, that kind of engine can be connected. In one engine, we can have 16 DPU or GPU, that kind of adapter. Therefore, for one big cluster, we can have 4,096 adapter be adding for scale up, that kind of capability. On the other hand, green technology. 1 unit can support more than 1 PB, that kind of density. And also, 1 terabyte only consuming 0.7 watt, that kind of energy, which is the lowest in the world. And support new data paradigm, for example, vector, and for example, tensor, etc., to really support the generative AI to have very efficient algorithm for learning. On the other hand, data resilience. The anti-ransomware, that kind of detector, is embedded with 99.99% that kind of accuracy. And furthermore, data fabric, that kind of capability is supported. Working together with DME can help our engineer to understand where is the data, how to organize them for generative AI. If we use OceanStor A800, the utility of the AI cluster can really be increased more than 30%. We could use less time for preparing the data and also less time for recording the checkpoint and problem recovery. By doing so, together with very high resilience for security, particularly anti-ransomware, that kind of functionality be supported. So it's really the powerful product for generative AI. For AI-ready data infrastructure, as we said, green, energy consumption, these kind of factor is really important. To overcome that kind of problem, media innovation is really the key and essential. Today, in my hand, this kind of size of disk, just the normal size, as we defined in U.2 standard. You know, how much capacity it supports? 128 terabytes, which is the highest density today we have. By using stacking technology in the chipset, we can reach this. By doing so, the space in the data center can be really saved by more than 80%. And also, the energy per PB also can be saved more than 90%, which is amazing. How our engineer realized this kind of product? Let's have a video. Same size, 10 times of the capacity, which will help our storage product to reach energy efficiency. Of course, to prepare for AI, actually need to be data ready at first. Right now, the difficulty for us, for example, like Huawei, it's a big company, yes, but we have data everywhere. Our CEO and the CIO don't know where is the data and how can we organize it as a material for generative AI. And then today, we bring a software embedded in DME, data management engine, which is Omni Dataverse. This software also supported by the metadata and also functions in the storage, OceanStor A800. By this software, it can help our engineer to understand where is the data, even they are located in different regions. And also, we could very easily to help our engineer to organize those data as a material for generative AI. And certainly, data lake is a good solution for generative AI as data infrastructure architecture. Omni Dataverse can really help us to easily build up data lake. We suggest the high-performance data storage doing tiering with capacity, that kind of type of storage. And then with support of Omni Dataverse, that kind of software, the whole data within that kind of lake, even they are located in different regions, can be well organized. How it works? Let's have a video. Right. Today in Berlin, on behalf of Huawei, I announced AI-ready data infrastructure. Particularly, we definitely believe a new definition for next-generation data storage is really needed. 6-dimension capability needed for the product. And also, we need a more innovative technology to develop new media for the storage with really high density, remember? And also, new data fabric, that kind of technology, and also software tooling system is needed to help us to build up AI-ready data infrastructure. Of course, no need to wait until generative AI comes to our database. Data has to be ready ahead of AI. Therefore, today, when you start to build data center, remember, try to use AI-ready technology, that kind of infrastructure, to make sure this kind of technology is ready. Therefore, no wasting of time and also investment for the future when generative AI, these kind of algorithms, really embedded into your data center. Today, in first level, we have demonstration area. Please take your time to have a look. All of these products and also technologies are detailed there. Please enjoy your time today. Again, thank you very much.